definitely going to want to be December 7th for corrections on that. And again, like I said, wind tide picks up again next week, so if you want to come in and visit me, choose me on those days, that'd be fine. I'd be happy to have you come in here today, okay? Guys, we're going to start getting into, we spent the whole chapter 3 talking about polynomial functions. Today, we're going to start getting into rational functions, rational expressions, and I got to be honest with you, everything that we're going to talk about in this chapter is going to deal a lot with exponents, okay? A lot of exponents, all right? And 4.1 is titled Finding the Nth Root and Rational Expressions. And our question today is, how can you use a rational exponent to represent a power involving a radical? Anybody know what a radical is? Besides you guys being radical, anybody else know what else a radical is? Kind of. You guys know that silly sign they make when we do square roots? You know what that symbol looks like? Almost kind of like a check mark thingy?
Yeah.
Yeah, that check mark thingy is kind of called my radical sign here. And we use that radical sign to come up with those types of numbers that Haley is speaking about over there to represent what's known as rational exponent or radical values, okay? Now, here's the question for you. Maybe some prior knowledge. If I ask you this question right here, what would you tell me this answer is? 4. Is 4 my only solution? I could say that this will be plus or minus 4. What kind of root is that, kids? That is a square root, okay? So whether you know this or whether you don't, we're going to talk a lot about it this chapter, but anybody know what value is up here by this square root symbol or this radical symbol?
1.
That's not quite a 1. It's actually a 2 that's up there, okay? It's a 2 that's up there, and yeah, the square root of 16 equal to plus or minus 4 there, all right? So what we need to make sure we're understanding is how can you use a rational exponent to represent a power involving a radical? Our goals today, first of all, what's the first one saying? I have a volunteer who would read that. Find the, yep. And we read this as find the nth roots of numbers. So we might be finding the square root, or the cube root, or the fourth root, or the fifth root. And what we're talking about is this. If I say, what's the fifth root of 32? We're asking ourselves, what number times itself 5 different times makes up 32? Okay, and I'm going to show you how to do that stuff today. Okay? Second one. How about volunteer to read my second goal?
Evaluate expressions with rational exponents.
Yep, evaluate expressions with rational exponents. Thanks, Bill. And then the last thing we're going to do is solve some equation using nth roots. And I'll show you how to do this here. Hey, my first question is, do you guys all have a calculator today? Everybody have their calculator ready to roll today? That's probably going to help, all right? Probably going to help. And if your phone just check it, that's fine. Yeah, you bet. Okay, vocab-wise today, there's going to be a little, there's going to be kind of some strange stuff here, all right? First vocab term up there that we're going to talk about is the expression or the phrase nth root of a. It says, in general, for an integer, n greater than what, kids?
1.
So we're talking about integers, whole numbers in other words, bigger than 1. It says if b to the n equals a, then we say b is an nth root of a. So example, if I say something like this, how about 6 to the third equals 216. If I say that, 6 to the third equals 216. What that is saying is the third root, this is saying the third root, or I guess I could say this. Maybe I should say it this way. I should say 6 is a third root of what, kids? Yep, in that first box, if I say this right here, I'll blow this up here in a second. Let me get that in there for you. I would say 6 to the third equals 216. This is really the same as saying 6 is a third root of 216. So what I could also say then is we look at it this way. We could write this as an index of a radical. And again, I'm not going to tell you to get too concerned about what the vocab means. I want you to understand what the vocab does. An nth root of a number is written as the nth root of 216, or in this case, nth root of a, where n is the index of the radical. This is really what we're saying, kids. We're saying put your 216 underneath the radical sign. Your index up here is a 3. What root am I looking for, kids? Or how would you read this, kids? Which root am I after? Third root of 216. What's this going to equal? 6. Okay, the third root of 216 would equal 6. So I think you have that. Okay. So this number up here, an nth root of a is written as a root where n is called the what again, kids? Index of the radical. Okay. All right, we know what a square root is. Square root is just simply going to be, as an example, maybe I have, I don't know, like the square root of 25. If I have just a square root of 25 written like that, there's no index up there, but anytime you have a square root, assume your index. Assume that index is equal to 2. So the square root of 25, even though there's not a sign up there, there's really a what up here, kids? Or an index up there, there's really a 2, okay? Kids, how about cube roots?
3.
Yeah, the index is 3. For cube roots, an example we just looked at, like this right here. For cube roots, that's how we would read them. Like the cube root of 216, your index is always what?
3.
Okay? And then I think you know what an exponent is. We're going to look at fractional exponents as they relate to radicals. And it's going to be pretty simple. But an exponent, if I wrote something like this, in, I don't know, 7 to the 4th power right here. In 7 to the 4th, what's the exponent? Which value? 4 is my... Four is your exponent. So kids, take a look at the vocab there. Make sure you have everything filled in there. Give you some examples of what the vocab means. All right, sometimes vocab is difficult when you have to read it, but if you can attach examples to it like we've done, makes it a little bit easier to understand. All right, you guys ready to rock and roll? Guys, it's Friday. We should be fired up. Woo!
Friday. Is it game day?
It's game day, but game day for Ellie. Game day for Ellie and Braden. Who else has game day today? Okay. You know who it's game day not for? Me. I'm gonna be gone today. So Ellie, you know what that means? Play hard, okay? Play hard, okay? You guys will have more fun without me tonight anyway. You know that, right? Okay. Hey, this is kind of an important one right here, and I'm not going to get too wrapped up in what that core concept says. Well, let's do this. First of all, core concept. We're going to talk about these index values, or these exponents, if you will, in terms of an even integer or what else, kids? Okay, let's talk about this right here. It says if a is less than what? 0, then there is no nth root, given that the integer is what kind of number? Even. If a is less than 0 when an integer is odd, it says that there's going to be what? 1 real nth root. And we'll come back to this table and we'll make some conjectures about some of the things we're about to look at. Let's take a look down here. What if a is equal to 0? Then what's it say? one real nth root. Basically, the nth root of 0 is going to be what? Because 0 times itself. I don't care how many times you take 0 times itself, it's always going to be what? 0. So what this is really saying is the nth root of 0 will always be what, kids? And we're talking about this a value being underneath the radical sign. And we'll show you what we're doing here. Over here, same thing. If a is equal to 0 and your integer up here or your index is odd, the nth root of 0 is still going to be what, kids? Okay? And then this last one. If we start talking about an index that's greater than 0, then how many real nth roots are you going to have? Well, 2 real roots. Okay, one's going to be positive, nth root of a, one's going to be negative root, nth root of a. They also express this as plus or minus a to the what over what, kids?
1 over.
And we'll talk about that here in a little bit, but just know that these two expressions right here and right here, they mean exactly the same thing, okay? They mean exactly the same thing. And over here, if you have an index that's odd, in other words, a greater than 0, then you're going to have 1 real nth root. So this right here, if you have plus or minus n root of a, that's going to equal plus or minus a to the 1 over n power. Now, I know it sounds confusing now. Let's put this into action and see what we've got here. Okay, example 1 says finding nth roots. All right, kids, I'm going to show you how this works. First of all, it says find the indicated real nth root or roots of what, kids? Of a. All right, first of all, take a look at your a value right here. Is this odd or even? It's odd. Is this odd number greater than 0 or less than 0? So this is saying we have an odd integer right here, and a is less than 0. So how many real roots are we going to come up with? It says just 1. There's going to be just one answer to this. Okay? So this table kind of tells you how many answers are there going to be. So here's how we write this. This is the same as saying, what's my index up here, kids? We're looking for the 5th root of what value? Negative 243. Now, I don't know if you can think of that value. What number times itself 5 times makes 243? Try negative 3 times itself 5 times. Does negative 3 work? Okay. Guys, I don't want you to have to struggle to find that, so I'm going to save you some time. Here's the deal. This works because negative 3 times itself 5 times is negative 243. So I would say the 5th root of negative 243 is what value, kids? Okay. Now, I want to touch on some of this notational stuff right below it. If I didn't write this way, I could have also written this as negative 243, kids, all to the 1 over n power, or to the 1/5 power like this. Okay, now I want to show you something. What's up here in blue is exactly the same thing as what's in red right here. These are notational things like this. Okay? The 5th root of negative 243 is the same as negative 243 to which power? 1/5 power. Let me show you in your calculators what you could do to save some time. So what I could do if I wanted the 5th root of negative 243, maybe your calculators have a button kind of like this. Do you guys have this, do you guys have a button that's like a square root? Oh, it might have, like this one right here for me has a square root. You see the little index of y out here over the x? Do you guys, I don't know, some of you guys, what are you guys using for calculators? Okay. How many are you? Okay. Tessa, you help. Carly and Tessa and Ellie. Who else? Ray, did you guys get together quickly? How many have the pink calculator, kind of like Belle has? You've got a different one. I'll help you out there.
Hey, look here.
You got it already?
I already know how to work.
You, my friend, would do, okay, you're getting second. Okay, so we want the fifth root, right? So you hit 5, and you go second, and then type in negative 243 like that. Okay, you go ahead and show the other kids with calculators. Did you get it?
Come here.
Okay, you want to do it? Which one do you have, Brandon? Just go, where is that? Let's see it. See if we can make it work. Who else has something other than those? Manny, do you have a phone for calculator?
Yeah.
Yes, scientific.
Pretty sure I already know how to do this.
Okay, so you are gonna go, okay, you're gonna take in 5. You see that
Look at that.
button right here where it's Y?
Yeah.
And then next with that,
Right.
and then I think take in 243. Okay, I'm gonna take this back. Here's what we're gonna do is this. You're gonna type in 243 plus minus 1. Okay, so this is the most one. So we'll name it Jessup. Plus minus, okay. And then hit this y to the x. Got it? Okay. Are you guys good on calculator? Good. Xavier, are you good? Guys all good on your calculator? Okay. I don't care how you typed it in. For me, I might have typed this in as 243. Negative 243, I'm going to hit this button. That's what I have to do in this one. Fifth root I want. What do I get? Okay, or I could have typed this in as 243 negative and raise it to what power? I could have raised it to the 1/5 power. Now, guys, when I raise this to the 1/5 power, where's my exponent key? Oh, where's it at? Tell me if I'm getting warmer. Where? Ah, right here, x to the y, right? Make sure you put that 1/5 in as probably a fraction inside of parentheses. Same thing, right? Thanks, bud. You start doing notes, your notes are in there, there's no sign, okay? So top, yep, just want to get caught up from somebody, and then we'll finish up on Monday, okay? Is your name on that sheet? Oh, no, I know. Yep, you're good to go. Thanks, Tyler. Have a good weekend. Okay, you guys try this one right here then. This wants which root, kids? 8th root of? Eighth root of 256. You bet. Two? You're getting 2? How many are getting 2 on that? Okay, let's talk about what this means. This is saying we want, okay, so 256. First of all, kids, this A value down here, 256, is this an odd integer or an even integer? Even. Is it less than 0, equal to 0, or greater than 0? So we're kind of talking about this situation right here. We're saying, oh, by core concept, we have a value that we're rooting out. We're looking for the nth root of, in this case, an even integer bigger than 0. It says we're going to have how many real solutions, kids? Okay, let me tell you what's going on here. We're looking for the nth root. In this case, our index is 8. Now, when you type this into your calculator, what do you get? 2. But when I say it's 2, it could be either positive 2 or what? Yep. So is this chart going to be important to you? Here's what I'm going to tell you. If you ever have a situation where this number is even down here and positive, what are you going to get? 2 real. Yes. Okay. Now I have to think on this. Yes, this is the case that we end up with, plus or minus 2. Okay. What do you guys think? You understand how to read that chart and apply it? Okay, let's move on to the next page. Next page. Oh my goodness me. All right. Evaluating expressions with what, kids? Rational exponents. I'm going to make this as simple as I possibly can on you. Rational exponents or fractional exponents, basically. All right? And when we look at this right here, kids, there's some things that we need to consider. There's some rules that you may have had in the past. I don't know. Hopefully you know them. If you don't, it's not the end of the world. We'll figure this out. 64 to the 2/3 power means the following, kids. It really means 64. Okay. There's a numerator and denominator in your fraction. What's the exponent that we're dealing with? Okay, what I will tell you is this. The denominator, and I'm going to make a note up here. The denominator, we can rewrite this in a situation where if we make the denominator your index for a root, we could write it this way. Square root of 64, but what's the index in 2/3? Or what's the denominator in that 2/3 exponent? It's 3. So we can make that denominator the index, and I'll show you why here in a second. All right? So this is kind of like which root of 64 first, kids? Third root of 64. Then, what we could do then is make the numerator the exponent. Okay, and let me show you why. First of all, 64, cube root of 64 is the same as 64 to the 1/3 power. Okay, that's 64 to the 1/3 power. Same thing, right? Okay, then I could take this mess now and square it. Ooh, what's 2 times 1/3, kids? What's 2 times 1/3 right here when I bring that in? 2/3 like the problem originally stated. So here's what I'm going to tell you. If you ever see fractional exponents, I want the denominator to be your what, kids? Index, and I want the numerator to be your what? Exponent. So here's how this is going to work. In our calculator, we're going to go cube root of 64. By the way, anybody know the cube root of 64 off the top of their head? What number times itself 3 times makes 64? 4 does. Okay? Then you would turn around and take that cube root of 64, which is 4, and now do what to it? This is the same as 4 squared, which is what, kids?
16.
Your answer here would be 16. Whew. Cray. Let me give you an example to try. How about we do 27 to the 4/3 power? Okay, so what would become the index here? So we've got which root of 27? And then, anybody know what number times itself? What is the 3rd root of 27? 3. So I've got 3 to the what now? 4th power. What is 3 to the 4th? 3 times 3, there's 2 of them, that's what? The other 3 times 3 is another what? Isn't that 3 to the 4th? What's 9 times 9? 81. 3 to the 4th would be 81. So 27 to the 4/3 power is going to be what? 81, you bet. So this to the 4th power would make your 81. Now kids, if I back up to the next example, how is this example maybe different than the first one of 64 to the 2/3 power? Dang it, there's a negative exponent in there. Don't let that deter you. Here's a rule for negative exponents. If you ever see a negative exponent, like a to the negative n right this is always the same as 1 over a to the positive n. Write that down somewhere on your notes. If you ever see a to the negative n like that, that's the same as what, kids? I'm going to tell you right now, you work a lot better when you're dealing with what types of numbers, negative or positives. You're going to love positives. So if you ever see a negative exponent, take this format right here and write it like this. Following me? So here's how we're going to rewrite that last example. We have 16 to the negative 5 over 4. We're going to call this 1 over what, kids? Well, 1 over 16 to not the negative 5/4 power, but positive 5/4. Now, we can work with this. We can work with this. Let's work with the denominator right here. That 16 to the 5/4 power. That's going to be the same as which root of 16, kids? What do you want your index to be? 4. All to what power? And what's still up top here, kids? Okay, can you guys think of the 4th root of 16? And if you don't know it, use your what? Use your calculator. Now you have to be careful on this one. Because the 4th root of 16 could be positive 2 or it could be negative 2. All right, does that make sense? Okay. So the 4th root of 16 is 2. Now we're going to take that 2 to what power? What is 2 to the 5th? Not 10. 2 to the 5th. 2 times itself, how many times? 30, how much? 32. But we also said that the 4th root of 16 could be negative 2. What would negative 2 to an odd power be? In this case, negative 5 power. Not positive 32, but... So my answers here potentially are positive 1 over 32 or negative 1 over 32. So in this one here, you're going to get plus or minus 1 over 32. So if you see a negative exponent, how are you going to rewrite that first, kids? What are you putting up top? 1, and then put your expression in the denominator, and your exponent switches from negative to what? Positive. And then evaluate the denominator just like we've been doing over here on the left, and you're on your way. All right, I want you guys just in your calculator, try these right here, see what we get for answers. Remember, if you have a fraction as an exponent, put what around that fraction? Parentheses. Let's just all see if we get the same value. It says evaluate each expression using your calculator, so to know that we're doing things correctly, we'll make sure we're good. It says round your answer to how many decimal places, kids? 2. So you go ahead and take a minute and do that. Check with a neighbor around you. If you're stuck on how to use your calculator, find somebody around you that can help you. Ouch. Might need more time. What'd you guys come up with 7 to the 1/4? So 1.63-ish? Anybody that did not have that? We okay with that? Okay, how about 10 to the 2/5 power? What'd you get there? 2.51? Okay. I'm a little concerned about this last one. Now, guys, a couple of ways. If I wanted to make this work easy, what's the index up here for this root of 11? I could write this as 11 to what power, kids? 2/3. If you want to punch it in that way and put the 2/3 in parentheses, I'm okay with that. Just recognize, maybe some of you took the cube root of 11 and then squared that answer. That's fine. Or if you recognize that the index is 3, I could move that out as the denominator for that squaring function. That'd be fine. What'd you guys come up with there? I'm sorry? 4.95. How many agree 4.95? I like it. Good. Guys, those are the 3 values you should get when you punch them in your calculator. Is there anybody that's having difficulty with that right now? Everybody getting those values? Awesome. Very good. Well, let's run into example 4. We're almost done here, kids. Run through example 4 quickly. Guys, solving equations using what? Okay, it says find the real solutions of what, kids? 5x to the third equals what? Okay, here we go. Here we go. We have to get x alone. So to get x alone, I would have to get x cubed alone first. So this 5 out in front of x cubed presents a problem. If I had 5x cubed equals 320, kids, you tell me what to do. What do you think you want to do? Say again, Braden? Absolutely. We've got to get x cubed alone before I can even get x alone. So we've got to get rid of this coefficient of 5. So we're going to divide 5. Oh, Braden, my north of Highway 3 math skills tell me that this is x to the third on the left. How about 320 over 5? 64. Now, this is where things get kind of good. Basically, this says x is a third root of what? So do you guys agree that x would become equal to the third root of 64? Okay. Cube root of 64 for me. I'm hearing 4. I want to go back to that chart again. N is what kind of an integer, kids? Is our index odd or even? Ooh, careful. We're looking for which root? The third. Is n odd or even, kids? It's odd, and our number is bigger than what? So we're going to have how many real roots? 1. Okay. So what is the cube root of 64? 4. And this one, x equals 4. Okay, let me show you how to handle something like the one on the right. Okay. This is saying some number plus 3 is the fourth root of what?
24.
Okay, let's look at this. This becomes x plus 3 is equal to the really fourth root of 24. Now, I want you to be really careful on this one. Okay, if I go back to my chart, look at your index here. Is your index odd or even? It's an even. So if I go back to the chart up here with my index right here, the index is even over here on the left. Kids, the value we're trying to find the fourth root of is bigger than 0. So how many real roots are we going to have according to my chart? 2 of them. Very good. So what I need someone to do is this. I need somebody to find me the fourth root of 24, and we'll go 2 places on that. So the fourth root of 24. Say that again. Ooh, that seems a little high. 2.21. Try it again, Jazzy. Go fourth root of 24. I think, make sure you've got the 2.21 for me, kiddo. Okay, so we all agree 2.21? So what this means, kids, is this. I'm going to make me a little... But kids, according to our chart, the fourth root of 24 could either be positive or it could be what? Okay, so we have this situation or we have this. So how many values are we going to find for solutions for x now? That x plus 3 could equal 2.21, or x plus 3 could equal negative 2.21. So to get x alone in both cases, what do we have to do to both sides now? Subtract 3. So if I subtract 3 here and 3 here, from this mess right here, we get x equals, oh, help me kids, is that negative 0.79? Okay, and then if I subtract 3 here and here, I get x equals negative 5.21. That's bad looking 5.21. Negative 5.21 is what that says down there. What do you guys think so far? You with me?
Yeah.
Any questions to this point? A lot of it's just punching stuff where? Calculator. You gotta know what the index is. You have to know what the a value is underneath the radical sign. Once you know those, I think you're in pretty good shape. Okay, last example. I should back up. Did anybody need more time with that page right there? Anybody? All right, I need a volunteer to read this last example for me. We'll get this done and we'll call it good today. You want to read that for me, a real life application? Mr. Parson will read it. A hospital purchases a machine for how much money? $75,000. That's like 2 vehicles. That's crazy. No wonder insurance costs are way high. The hospital expects the useful life of the machine to be what, kids? It says at which time its value will have a, what's this word mean? Depreciated. What's that mean? The value of something goes down over what? How many of you had parents that have purchased a new vehicle before? And they've ever heard the saying that once you drive it off the lot, its value is what? It's like much less, right? That's depreciation. Okay? So it was purchased for $75,000, probably worth that to begin with. Over 12 years, its value is now how much? $15,000. Okay, it says the annual depreciation rate R in decimal form is given by the formula R equals 1 minus capital S divided by C to the 1 divided by n power, where n is the useful life of the item. In what? How many useful life years were there again? 12. Okay, and C is the original cost in dollars. Okay, S is going to be the salvage value in dollars. What's the salvage value? It depreciated to what? Okay. It says, what's the annual depreciation rate that the hospital uses here? Here we go. We're just plugging numbers into this formula. R is going to equal, here we go, 1 minus, what's the salvage value, kids? In other words, how much is it worth after 12 years? So we're going to go 1 minus 15,000 over, what's the C value? C was given to us as the original cost, $75,000. And then this is all to the 1 divided by n, where n is the usable life. How many years life did they get out of this thing? So we're going to raise this to what power? Okay. So here's what we're going to do, kids. We're going to get on our calculator, and we're going to say, hey, let's figure out what that 15,000 divided by 75,000 is. What do I end up with? 0.2. Okay. We're going to say this is equal to 1 minus 0.2 to what power now? 1/12. Okay. So we're going to punch in that 0.2. We're going to find the 12th root of 0.2. So I've got this 0.2 right in here, guys. We're going to raise it to which power? So I'm going to go 1 divided by 12, making sure I put the 1/12 in. Yep. And I'm going to hit equals. What do you guys get? 0.8744. So we'll call it 1 minus point, I don't know. I'm going to call it 1 minus 0.874. Okay. So if I go now 1 minus 0.874, this is what I get. I get 0.126. Okay? I get 0.126. So what this means, kids, is the following. It says, what annual depreciation rate did the hospital use? Okay? Annual meaning every what? Every year. So we would say that, what would 0.126 look like as a percent? So I'm going to say the value of the machine depreciates what percent? Depreciates 12.6% per what? Per year, or what's another way of saying per year, kids? Annually. Very good. The value of the machine depreciates 12.6% annually. So the annual, whoops, can't spell today. You bet the value of that machine is going to depreciate 12.6% annually. So what percentage of depreciation did they put in for each year? 12.6%. Kids, questions today? All right, I'm going to stop this here.